Welcome back to What Your GP Doesn't Tell You, the podcast for both doctors and patients, with me, Liz Tucker. In this week's episode, I'm talking to Dr. Bill Harris, who's been a pioneer in uncovering the critical impact that the omega-3 fatty acids have, not just on our heart health, but on a myriad of other health conditions. Ever since Bill gave a fascinating presentation at the Integrative and Personalised Medical Congress in London last year, I've been really keen to get him on the podcast. In our conversation, he stresses the crucial importance in getting enough omega-3, which is why he thinks the UK NHS's advice on limiting our oily fish intake is wrong and badly out of date. Bill argues that the heavy metal risk from oily fish is much reduced today. And in what I feel will be a surprise to a lot of people, Bill explains that he doesn't believe seed oils are problematic and reveals why it's important we also get enough omega-6, which these oils contain. But before we get to Bill's interview, a brief request from me. If you enjoy this podcast and would like to leave a review on Spotify or Apple, that would be much appreciated. It really helps. You can also become a paid supporter of the podcast at patreon.com/whatyourgpdoesn'ttell-you or via PayPal on my website, whatyourgpdoesn'ttell-you.com. A huge amount of work goes into both the research and production of this podcast, so even a small amount of money makes a huge difference. And you can find out more information about the pod on my website, where you can sign up for the podcast mailing list, follow me on Twitter at Liz C. Tucker, and on my Substack account, liz.tucker.substack.com. Many thanks. Now back to Bill's interview. Dr. Bill Harris has been a leading researcher in the omega-3 fatty acid field for 40 years. He's authored over 360 scientific papers on fatty acids and health, the vast majority on omega-3. And Bill's received a number of US National Institutes of Health grants to study omega-3. He was also the co-author on 3 American Heart Association statements on fatty acids and heart health, and is the co-inventor of the omega-3 index and other omega-3 blood tests, and founder of Omega Quant Analytics. Here's Bill's interview. Well, Bill, thank you so much for joining the podcast today.
Happy to do it.
Bill, how did you first become interested in omega-3?
My first encounter with it was 1979 with a researcher in Portland, Oregon, who was named Bill Connor, who was very interested in the effects of different dietary fats on cholesterol levels, which we didn't understand all that well in the 1970s. We knew that plant oils lowered cholesterol. We knew that animal fats raised cholesterol. Bill thought, well, what about fish oil, fish fats? Because they're liquid at room temperature, like vegetable oils are, yet they come from an animal. Is it the liquidness or is it the animalness versus plantness that affects cholesterol levels? So he said, let's do a study on salmon oil. And in the Pacific Northwest, there's a lot of salmon, so it was pretty easy to get salmon. So we organized a study and we fed people lots and lots of fish oil, salmon oil, about 100 milliliters a day, far more than the Eskimos ever ate. We wanted to aim high and see if it had an effect. That's when we discovered that omega-3 fatty acids lowered triglycerides. This was right around the time that the Eskimo studies from the Danish investigators were starting to get some headlines. We were kind of there near the beginning, and I continued to be fascinated by omega-3s and their health effects.
People often think that they can get omega-3 from foods such as flaxseed oil, but the reality is they can't because it's not easily converted by the human body.
That's correct. There is an omega-3 in flaxseed oil and in soybean oil called alpha-linolenic acid, ALA, but it's a shorter, simpler version of the omega-3s you get in marine products and fish. So the body has to make a conversion. It is a difficult conversion to make. The process is not efficient. It's not a substitute for fish oil.
So really the only sources are fish, and these contain the vital EPA and DHA.
Yeah. Of course, you can get algal oil, single-celled algae, not seaweed, special species of algae that make it in the ocean, and those have been harvested. and used to make EPA and DHA directly by fermentation of these algae. So it's not actually a marine omega-3, but it is EPA and DHA. That's where they come from. Really, fish oil, krill oil, algal oil, a thing called cannabis oil is another seafood type omega-3 product.
So it's interesting that quite often vegans or vegetarians have low omega-3 levels, but from what you're saying, actually, they could have algal oil. So there are solutions to that.
They could. Yeah, that's true.
If you look at a map of the world, of the countries that tend to have higher omega-3 levels, those all seem to be areas where people eat a lot of fish.
That's not a coincidence, especially oily fish. In the United States, we eat a fair amount of fish, and you do too in the UK, but it's typically fried white fish, and that doesn't have much, if any, omega-3 in it.
Now, Bill, you actually developed a blood test to measure omega-3. How did that come about?
In the early 2000s, a colleague of mine, Dr. Clemens von Schacke, who was a cardiologist in Munich, he and I both had been omega-3 researchers for some time, and we were at a meeting together in the American Heart Association meeting in Chicago, and a paper had been presented showing that people with the highest red blood cell omega-3 levels had the lowest risk for sudden cardiac death. And this was a confirmation of a previous study from 1995. It looked real. And so Dr. von Schacke and I were musing about the fact that there really ought to be a test because it really is a predictor of an important health outcome. It's expanded since then, but that was the idea where the omega-3 index was born, which is the red blood cell EPA DHA level, which we think is really the best biomarker of your omega-3 status in your body.
So how exactly is the test making its measure?
Mechanically, people will either have a blood draw from in a blood tube and sent to a laboratory, or they do a finger stick, poke on the finger and a collection of blood on a card, and it's mailed to the laboratory.
So it's measuring the percentage of fatty acids which contain EPA and DHA.
Yeah, we're focusing on the red blood cell, which is like any other cell in the body, has a lipid bilayer membrane. Membrane is made up of fatty acids in the form of phospholipids, but they're primarily fatty acids make up that membrane. And so we're looking at EPA and DHA as a percent of the total fatty acids in that membrane.
And it might just be useful spelling out for people who don't know what EPA and DHA is.
Yeah, sure. EPA and DHA are the two long-chain marine omega-3 fatty acids we get from fish. The real names are eicosa pentaenoic acid. Eicosa means 20. Penta means 5. Enoic acid means it's a fatty acid, so it's a 20-carbon 5 double bond molecule. DHA is docosah, which means 22. Hexa, 6. Enoic acid, so it's 22-carbon 6 double bond fatty acid. So that's EPA. Thank God we can say EPA and DHA.
You can see why they came up with the abbreviation.
That's right.
And how did you decide what should be an appropriate omega-3 target? What are you looking for in the blood?
Yeah, that's a good question because we were proposing back in 2004 is when we first published our paper. We proposed that the omega-3 index would be a risk factor, very much like cholesterol or blood pressure or other metrics that the doctor will measure and assess your risk for different diseases. And in proposing that as a risk factor, you've got to give a target. You got to give this is too high, that's too low. You got to send something. So based on the evidence that was available at the time, we estimated that an omega-3 index of 8% or higher would be the optimal goal. And 4% and below is the place you definitely don't want to be. And then kind of 4 to 8 was sort of in the middle, better, but not great. And so we set up those targets at that point. And I think over the last 21 years now, we've seen that those targets have pretty well confirmed, but they still hold true.
And when you were coming up with those figures, were you looking at the countries where they have the high level of omega-3 to give you some kind of baseline?
That was a piece of the story. Mostly it was observational research studies or intervention omega-3 treatment studies. And we either knew what the omega-3 index was from those papers, or we estimated it based on some scientific assumptions based on experiments we'd done. So we kind of came up with 8 or 10 different studies and what was the blood level of omega-3 that was the most helpful in each one of those studies. And we just took the average of all those levels, and it turned out to be 8.1%. So we said, 8%, that's good.
And are there any risks to having too much omega-3?
Not that we really know of. There's very few populations or people around the world that have omega-3 index of 8% or greater. Japan is one. If there's any risk factor, it's pretty well hidden because Japanese live on average about 4 years more than we do in the United States, despite the fact that they smoke more, despite the fact that they have more hypertension. They still live longer. I can't attribute all of that to omega-3. I'd like to, but that's naive to do that. But if there's any problem with having a high omega-3, it's not been evident in the Japanese. Now, I will say there are two concerns that people often bring up. One is risk for bleeding, because the omega-3s do make your blood thinner, so it doesn't clot quite as easily.
Hence preventing heart attacks.
Exactly. That's why people will take aspirin to thin the blood. And the omega-3s do that. And there was always been concern that, well, maybe you're thinning it too much, but the evidence to date shows that even in people who are taking blood thinners, if they have atrial fibrillation, they're taking a Coumadin or something to thin the blood, there's no increased risk for bleeding when you also add on omega-3. And that's been confirmed in meta-analysis recently. The other issue that's popped up in the last 2 or 3 years is atrial fibrillation. What we know at this point is there's a small increase in risk for atrial fibrillation in a particular setting. When patients are giving like 3 or more grams a day of EPA and DHA, and they are at high cardiovascular risk to begin with, and if they have a history of atrial fibrillation, all those things together, you see an increased incidence of AFib in the omega-3 group. It's about a 1% increase, 1.5% increase in risk, absolute risk for AFib in people who are taking omega-3. In the general population, taking a gram and a half of omega-3, there's no evidence that the omega-3s are increasing risk for AFib. In those high-risk populations given high doses of omega-3, that's where it's showing up.
And what would be the biological mechanism that would explain that?
That's a great question, in which we don't know the answer. We think it has something to do with kind of a chronic inflammatory state that can lead to AFib. There are some people who are like really well-trained athletes who have really slow heart rates. And if you take omega-3, that will actually help increase vagal tone. The parasympathetic tone goes up, which will, in people that have a really slow heart rate, that can tend to throw them into AFib. But honestly, we really don't know what the causes are.
You don't really think there's too great a risk if people take too much omega-3, and you were pointing to Japan, for example. But sometimes when people start to supplement, you're able to take much more of a particular substance than you would if you were just eating it as a food.
Right. Becomes kind of self-limiting. Most omega-3 supplements, a good one is going to be 500 to 1,000 milligrams of EPA and DHA, maybe 500 or 700 per capsule. So if you take 3 capsules, about 2 grams of EPA and DHA, most people are not going to take that much omega-3. Obviously, you can, but in practice, most people will say, well, I've got a fish oil, I'll take 1 a day. And they're getting in that one, maybe 500 or 700 milligrams, which is fantastic, 5 to 7 times the normal intake of EPA, DHA. But once you get up to 2 and 3 of these big pills a day, that's becomes kind of self-limiting unless you're, being told by your doctor to take 4 of these pharmaceutical grade omega-3 products to treat some condition. Then you'll take 4.
There have been a number of studies, Bill, looking at the various possible health benefits of omega-3, and I'd like for us to take a look at some of them if we could.
Right.
And I'd like to start with an early 1995 study from the Journal of American Medicine, or JAMA for short, that looked at patients who had blood drawn after a heart attack. What did that show?
Right. That was really the first glimmer that the omega-3 index makes sense. That was a paper by David Siskovic and his colleagues in Seattle, Washington. As you mentioned, they actually drew blood from patients just as they were having their heart attack. They were able to get a blood sample at that moment. After several years of doing this and collecting blood and freezing it away, they were able to thaw the blood samples out and compare the levels of omega-3 in those people having heart attacks with other people in the community who are the same age, same race, same sex, try to match all these characteristics. Say, what's different about these people that are having heart attacks? Well, they had really low omega-3 levels. When you divided the group into quartiles of omega-3 level from the lowest 25% to the highest 25%, those who were at the highest 25% were like 90% less likely to be a heart attack case. And that was what the 2022 study from Christine Albert in New England Journal kind of confirmed, except they did it without drawing blood from people who were having heart attacks. They had drawn blood from people who were perfectly healthy. And then they saved it for 17 years. And after that period of time, a certain number of those once healthy people had actually had sudden cardiac death, primary cardiac arrest. And they pulled their blood samples out from when they were healthy and measured the omega-3 and compared it to the levels and, again, controls. And again, those in the highest 25% were 90% less likely to be cases. So it confirmed in two very different settings that a high omega-3 was at least associated with a lower risk for sudden cardiac death.
I think there was a further study also, wasn't it, in a hospital, which compared patients with acute coronary symptoms against other patients.
Yes, yeah, that's a study we did when I was working in Kansas City. And we compared about 750 people who had been admitted with a heart attack. This wasn't, right when the ambulance showed up. By the time they got in the hospital, we had their blood. And we compared that with levels of omega-3 and other people just coming to the hospital just to give blood for their upcoming doctor visit. Same story. We found that those who had been admitted with an acute coronary syndrome, this is a heart attack but not fatal, had significantly lower omega-3 levels than the general population. So once again, there's a signal there. These are all association studies, which is what you do in this kind of research, but they point to the idea that a low omega-3 is a risk factor for cardiac disease.
Well, as you rightly point out, Bill, they are associations, aren't they? I mean, is it possible that healthier people, as part of their diet, ate more fish, had a generally healthier lifestyle, and that omega-3 was just a marker for this?
Yeah, that's a common concern about studies like this, particularly if you do studies where you're asking questions about diet, and the people who report eating more fish typically have better health outcomes. Is it because they're eating fish or because of what they're not eating instead of fish? That's always a question. We try our best to control for those things. Most of our studies are not done based on dietary questionnaires, but they're based on measuring blood levels of omega-3, which is a far more objective measure of the status of omega-3 in a given person. It's driven by diet to a large extent, but there's metabolism in there too. Things get changed. So that's a more objective measure of omega-3 intake, if you will, than a dietary questionnaire. But you have the same concern that the people who have high omega-3, maybe they're just healthier in many other ways. Well, true, that could be, but we control for whether they're smokers or not. So if this is independent of whether they're smokers or not. We control for whether they have diabetes, whether they have hypertension, whether they're overweight or underweight, whether they're older, younger, male, female, control for different socioeconomic variables. So hopefully those things are all taken off the table as potential explanations, and you're kind of left with, well, it's the omega-3s. They're actually doing something. It's not just that they're a marker for a healthier diet. There's way too many diseases now where we see a relationship between higher omega-3 and lower risk for that disease. And you can't attribute a specific lifestyle to being lower risk for dementia and heart disease and cancer, osteoporosis. It just doesn't make sense. So I think we have to face the fact that the omega-3s really are active. They are playing a causal role in this.
You mentioned that it operates as a blood thinner. Do we know what else it's doing in our body?
Probably the more common thought about what omega-3s do is that they're anti-inflammatory in a very broad sense. I'm just working on another paper right now where we're looking at 10 different inflammatory markers, different chemicals in the blood that would be elevated if you're in a pro-inflammatory state. And we're looking at the question of omega-3 levels related to those inflammatory markers. And what we found was the higher the omega-3 level, the lower the levels of all those inflammatory markers are. So it's across the board an anti-inflammatory.
It's interesting because certainly in the UK, I think a lot of people think about fish oils for heart health, but I don't think people necessarily think of them so broadly for a wide range of chronic health conditions.
people can be excused for thinking it's a heart deal because for 20 or 30 years, that was it. Other than the interest in omega-3 in early development in pregnancy, which was a whole parallel line of research where the omega-3s were shown to be important for babies' brain development and eye development. That didn't get much press. What got press was heart disease because that's what was killing people and still is. But in the last several years, in one big study in the UK Biobank, as well as looking at multiple cohorts around the world, we look at the blood levels of omega-3 in these people and then look over the next 10 to 15 years to say who's dying of what. We find consistently that the higher the omega-3 level is when we originally test them, and then we follow them for many years, the higher the level is, the longer they live. The less risk they have for not just cardiovascular disease, but also for cancer and for all other causes combined. So it's not just heart. There's something the omega-3s are doing across all health systems that are reducing risk for these adverse outcomes.
Because I think actually in 2021 in Nature Communications, you were the lead author on a paper which looked at 17 studies, which seemed to suggest there was benefit beyond heart disease, cancer, other causes of death.
Yeah, we were looking at causes of death.
Yeah.
First of all death, and then reasons for dying. And that's where we saw this relationship, looked at 5 different levels of omega-3 in the blood. And across all 5 of those levels, called quintiles, we saw a reduced risk for, again, all-cause mortality, cardiovascular mortality, cancer mortality, and whatever's left in one big pot, lower risk.
So across all of these deaths, the greater your level of omega-3, the lower your risk of death.
Yeah, I mean, it doesn't mean that omega-3 is lower risk for every cause of death. We didn't look at every possible accident, suicides, COPD, kidney disease, all those things. We wanted to do big buckets. The biggest bucket is total mortality, all cause. And then we wanted to look at the major causes, cancer and heart disease. And then without getting too crazy, just say everybody else and just ask, is there a relationship there?
And when you looked at these different causes of death, did you see a greater effect in some causes of death, or was it fairly uniform across all disease types?
That was just too complicated. We had 17 different statisticians around the world doing analysis on their own data sets, and then they sent us the results and we pooled them. But in a parallel paper, I know this is getting a little bit off the omega-3 topic, but we did a similar type of study looking at omega-6 levels in the blood in the UK Biobank, and particularly linoleic acid, which is the primary omega-6 in our diet. And we found the same thing we found with the omega-3s. For linoleic acid, higher levels of linoleic, more omega-6 in the blood, lower risk of total mortality, cardiovascular, cancer, and other. And in that study, which was done, again, only in the UK Biobank, we were able to look at 8 other causes of death. And it looked like it was pretty consistent across digestive diseases, respiratory diseases, musculoskeletal diseases, neurologic diseases. Higher omega-6, higher linoleic acid was protective across the board. Again, that steps out of the omega-3 story, but I do want to leave your listeners with at least a little bit of understanding that the omega-6 fatty acids are not bad for you.
What one hears quite a lot is the ratio that one should have between omega-6 and omega-3. What's your view on that?
My view is rather stilted on that. I'm not a fan of that idea, partly because, as one of my colleagues said, what's the point of making a ratio of too good to a good? Usually make ratios of good to bad. But people have got it in their minds that omega-6s are bad, omega-3s are good, and they live and breathe that. And there are many, many problems with that metric. Number one, the first one is the omega-6s are not bad. The primary omega-6, linoleic acid in our diet, is good. It's good for reducing risk for heart disease, diabetes, and again, total mortality.
And can you explain where omega-6 comes from?
Sure. The primary source is from what we call seed oils, soybean oil, corn oil, safflower oil, sunflower oil. Those are really the rich. Canola has some omega-6. Olive oil doesn't have much omega-6. It's mostly a monounsaturated oil.
Well, it's interesting that you bring in the seed oils because a lot of people are quite anti-seed oil now, aren't they?
They are indeed, for completely irrational reasons, in my view. Part of their dislike of seed oils is the idea that omega-6 fatty acids are pro-inflammatory. We are showing they're not pro-inflammatory and they're protective, but nobody seems to want to listen to that. The other reason they say they don't like seed oils is because they don't like the fact that fried foods are cooked for a long period of time, fast food restaurants. The oil is heated and it's oxidized, yada, yada, yada. And so eating the foods that are fried in those is bad for you. I mean, that's not the problem with seed oils. The problem is, if there is a problem, is with heating for a long period of time. I mean, it's treating the oil badly. You can't blame the seed oil for that. You blame the restaurant company for that.
If you heat olive oil above a certain temperature,
Oh, yeah.
it will also have a similar effect.
Right. And olive oil has got a variety of other chemicals, polyphenols and things like that the seed oils don't have. So actually, olive oil is a fruit oil in a sense. It doesn't come from the olive seed. It comes from the olive fruit. Whereas corn, soybean, again, cottonseed, they come from the seeds. I'm not an expert in the ins and outs of the effects of heating, for how long, at what temperature, for all these oils. Just the fact that an oil is processed, that word just doesn't mean anything.
I mean, I would have lost count of the number of people on this podcast who would have expressed concern about seed oil. And I think, as far as I understand it, their argument is because it requires more pressure and a greater industrial process to get the oil out of the seeds, as opposed to olive oil, where you can just use your olive press or avocado oil or something.
Yeah, just because something is processed, it shouldn't be a plus or a minus for its health benefits. I mean, it's silly. We process water every day before we drink it.
Yeah.
I mean, it's just a stupid word to use if you're trying to be precise.
That's really interesting, Bill, because you see so many things about how in the West our omega-6 levels are too high compared to our omega-3. That's all the time.
I know. It's just wrong. Just tell I'm on my soapbox here.
This is interesting and important, I think, because it's not something people hear a lot.
Well, yeah, another problem with omega-6, omega-3 ratios, you can have a high level of omega-6 and a high level of omega-3 in your diet and have the same ratio as if you have a really low level of omega-6 and a low level of omega-3, and the health effects are vastly different, but you got the same ratio.
I'm beginning to think I should be eating some more omega-6 now, Bill, actually, because I think I'm fine with the omega-3.
Yeah, I don't think you should be avoiding it. That's kind of what I'm concerned about is the push to remove it. It's going to turn out to be like the trans fat story, where one time we thought it was great until we looked back and said, oh, rats, that wasn't good. And I think removing omega-6, all of our data, observation, hundreds of thousands of people, many years of follow-up. If you lower omega-6 levels, you're going to increase risk for diabetes and heart disease and total mortality.
Well, that's interesting because I use olive oil, avocado oil, and butter and dripping. And those are the oils I use. So actually, I need to be getting back the seed oils, basically.
Well, I don't think it's a bad idea to start including some high omega-6 oils in your salad dressings and things like that. You don't have to fry in it. You can use it in other foods, bake with it. Anyway, I digress.
One study that I thought was particularly interesting looking at omega-3, and that was the relationship between telomeres and omega-3. And just for any listener who's not clear, telomere is a region of repetitive DNA sequences at the end of a chromosome, and they protect a chromosome from becoming frayed or tangled. And they're a sort of molecular timer limiting the number of times a cell can divide, so often play a role in aging and cancer development, is thought. So it's potentially significant if they're linked to omega-3, isn't it?
Yeah. And this was a study we were involved with many years ago with the group at UC San Francisco, where they measured omega-3 blood levels in about 1,000 men and women who had heart disease. And at the same time, they measured how long the telomeres are. So as you mentioned, it's at the end of each chromosome. It's sort of like the little plastic tip on your shoelaces that locks them together so they don't get all frayed. Every time your cells replicate, you get a replication division of cells into mother cells to daughter cells to granddaughter cells. all the DNA is transferred from the one generation to the next in those cell divisions, except a little bit of the telomere is not quite transferred. So you can measure how fast your cells are turning over, how fast you're aging, you're biologically aging, by how fast those telomeres are shrinking. So in this particular study, 1,000 people measured omega-3 levels at the beginning and telomere length. And then over 5 years, they measured the telomere length again. And so that you could tell whose telomeres shrunk and whose didn't. And we found a really strong relationship. The higher the omega-3 level was, the less telomere shrinkage occurred. I mean, it fits with the idea that we have lower risk for death.
Yeah, makes sense.
With higher omega-3. It fits with the fact that Japanese with high omega-3 live longer than people with low omega-3. A recent study came out of Switzerland. It was a study where they gave, for about 3 years, they supplemented a group of people with omega-3 fatty acids. And they measured these things called biological clocks, which you've probably talked about on your podcast. Researchers are coming up with different ways to sort of say, well, what's your real age according to your own body, not just the calendar? Is your body really younger than your birthday says it is, or older? And those are biological clocks. And they found that the biological clock over a 3-year supplementation period, the people who got the omega-3 aged 3 months less than the calendar said they did.
And this is over 3 years?
Over 3 years, just over 3 years.
So if it was a linear relationship, a year, a decade?
Yeah, a month for every year. So in a way, yeah. I'm not sure how far you can extrapolate it.
Or indeed if it's a linear relationship.
Right, it could plateau out or something like that. But there was an experimental demonstration that the omega-3s can actually slow your rate of aging, which fits with a bunch of other data. That's exciting. We're going to be looking at that ourselves in some new studies.
And do you have any theories, Bill, as to what might explain what the omega-3 is doing?
Well, everybody always reverts back to the good old chronic inflammation.
I understand the chronic inflammation, but when you actually drill down into the biology, what is it actually doing to our cells?
I will often say the omega-3s, they make their home in cell membranes, which is one reason we like to measure red blood cell omega-3, because they get in the membranes. And they affect the functionality of the membrane. Membranes are not just inert envelopes. They're very active. And if you can sort of think about your house, inside your house, there's stuff you need to get inside your house, like food needs to be brought in, and the trash has to be taken out. Consider on a cell membrane that there are doors that swing open and closed that let good things in and allow bad things out. And if you think about these little doors, they're receptors, transporters, more technical terms. If you think about them being kind of rusty, like they don't swing open and swing closed like they should be, it's harder to get the good stuff in, it's harder to get the waste products out. That's what the omega-3s kind of fix. They sort of oil the hinges on those doors. And when those doors aren't working right, the cells will die more quickly and it has to be replaced. So that's where you did the telomere shrinks. It's partly an inflammation thing. Sometimes you need to make anti-inflammatory molecules. The cell needs to get the message that we've got to cut, we've got to bruise, we've got to heal it. So we send a message to the cell lets the message come in the door, and the cell makes the proper molecules to treat that problem, acute problem. Again, the door on the way out is nicely hinged. The stuff can come out and you get healthy again. But if you don't get that signal through, the inflammatory reaction just builds and builds and builds. Kind of an anti-inflammatory effect would be generally explained by just having less stress on all of your cells, all of your life. You're improving the in and out, those doors, you're putting oil on the hinges of those doors.
Now, the UK Biobank study that you touched on earlier, which is actually looking at COVID outcomes and comparing those with levels of DHA in the blood, one of the things that was surprising to me was it showed a reduction in hospitalization and death, which perhaps, given what we've been talking about, isn't surprising. But what I found really puzzling was it seemed that people with higher levels of DHA were actually less likely to get infected to begin with.
You and me both. That was not part of anybody's idea that that's what would happen. And we saw a dose-related relationship. The higher the omega-3 status in those people, the less likely they were to test positive. So are they able to fight off the invading virus better so that they don't actually become infected? Could be. There's some evidence from more basic science studies. You remember the spike protein?
I do.
It has, I guess, kind of an open and a closed conformation. In order for the receptor on the cell to recognize it, it's got to be, I can't remember whether it's open or closed, but let's say it has to be in this closed configuration to be taken up and brought into the cell where it then will replicate and make more viruses. People have shown that having a higher level of DHA in the blood or in the membrane keeps that spike protein open so it can't be picked up by this receptor. If that's true, I mean, that's a big leap. But if that's true, that would explain less actual diagnosis of infection.
Because one of the things I wondered was whether there was any socioeconomic data on levels of EPA and DHA. Because if potentially perhaps the better off are more likely to eat fish and take supplements, certainly in the UK during COVID, that was the group who was safely working from home, where it was the poorer workers, say bus drivers, shop workers, who were more exposed to the disease.
In the UK Biobank, they have a metric called the Townsend Deprivation Index. It's a conglomerate measure of how deprived relative to the average you are. And so if you have a positive number, you're more deprived. If you have a negative number, you're less deprived. So that would be kind of socioeconomically. We always adjust for that in our analysis. That should not be a factor in the relationships we're seeing. But to your point, we have never asked the question, what is the relationship between the blood DHA level and that index? I mean, that would be a very simple study to do, actually. And I suspect we would see that, yeah, the higher the omega-3 levels, the less and less deprived you are.
Now, there are also studies which suggest that EPA and DHA may be protective for brain health, which is what a Women's Health Study Initiative suggested.
That's true. The fact is that DHA and arachidonic acid, really two of them, are the most abundant polyunsaturated fatty acids in the brain. Not EPA, but DHA. And so people have thought, I don't know, maybe some of these mental disorders, depression, for example, might be related to how much omega-3 is there. And so several trials were undertaken with people with depressive symptoms to try to see if giving EPA or DHA would change the score on these symptom tests. You can give omega-3 products that are rich in DHA and low in EPA, or vice versa, high in EPA, low in DHA. And both of them have been tried. And it looked like the products that had the more EPA rich have been more often successful in affecting depression symptoms, which is contrary to the whole idea, well, it's DHA. That's why you do research. You find out stuff that you didn't expect. But depression's one thing, dementia is a completely other thing.
I mean, there's increasing evidence, I think, that inflammation plays a big part in dementia. A lot of people refer to it, in fact, as diabetes type 3, don't they?
Right, exactly. We reported in a couple of contexts, and we're still doing another big study on that higher levels of omega-3 do predict lower risk for dementia, presumably via some kind of anti-inflammatory effect. That's encouraging. With dementia, we have so few tools, quite a few tools to try to prevent it, but we have very few tools to treat it.
I think there's some interesting research on the west coast of the States, particularly looking at a mixture of diet, hormone, brain training, basically removing sugar from people's diets, quite often using a sort of ketogenic approach, which does appear to have some promising results.
I agree. There's a lot of really interesting nutritional research on dementia, absolutely. And sugars are part of it. Ketogenic diet may be a part of it too. Certainly, a ketogenic diet, low-carb diet that emphasizes high fat and protein, you could certainly include salmon and sardines and omega-3 rich proteins, so to speak. I think that would make a lot of sense.
Now, the Women's Health Initiative also showed a relationship between hippocampal size and omega-3.
Yeah, that's another study we did in the Women's Health Initiative. Specifically, it's called the Women's Health Initiative Memory Study. or WHIMS. We measured omega-3 levels in about 6,000, 7,000 women in that study. Then they did brain scans, MRIs of the brain, and they could look at the hippocampus, which is that kind of the memory center, a small section of the brain in the middle. We could look at the size of that, the actual volume of the hippocampus. One of the features of dementia is the physical shrinking of the size of the hippocampus. And we found that people that had the highest omega-3 levels had less shrunk hippocampal volumes. And that matched with certain other studies where we looked at cognitive function and memory and things like that. I mean, these women were in their 70s. We did a similar study in Framingham in what's called the Framingham Generation 3 cohort, where we looked at cognitive function testing in people in their mid-40s. And even there, higher levels were related to better function. So I think starting early, getting omega-3 levels up is important.
After listening to this, I imagine that's what listeners will be thinking, Bill. So how much fish do they need to eat? And is fish on its own enough?
Well, as kind of alluded to earlier, there's fish and there's fish.
Oily fish.
Yeah, oily fish. There's kind of an acronym we use: SMASH, S, salmon, M, mackerel, A, anchovies, or I don't know who eats anchovies.
They're delicious, actually, when you put them in with a lamb stew, or when I make salmon fish cakes, I always throw in a few anchovies.
Okay, good. Well, you're not eating like 100 grams of anchovies.
No, that would be tough.
But maybe ahi tuna or albacore tuna could be the A. That's a higher level of omega-3. The other S is sardines, and the next one is herring. Those are really the high omega-3 fish. And eating those, a standard serving, 100-gram serving of salmon, you're going to get maybe 1.5 to 2 grams of omega-3, EPA, DHA, which is great. So eat that every day and you're set. You don't have to take any capsules, any pills, or anything. Or, alternate that with tuna or alternate that with a can of sardines or something. And you can certainly get an omega-3 index of 8 and above with just fish.
So how many portions of fish should we be eating a week, would you say?
And, everybody says 2 or more. I think maybe 4 would be optimal.
Now, I love fish and seafood. It's one of my favorite foods. But one thing that I'm always conscious, this obviously varies with the different fish I appreciate, is heavy metal content.
Yeah.
And it's something that I know the NHS talks about.
Yeah. In the US, we're concerned particularly about 4 different species of fish when it comes to mercury: king mackerel, shark, swordfish, and a thing called tilefish.
What about in European fish? So in this country, say wild salmon, mackerel, sardines, herring would all be popular oily fish.
Yeah, and those are very good, and they're very, very low in mercury.
So if I'm eating, let's say, 3-4 portions of fish a week, that would be enough on its own without me having to take an EPA and DHA supplement as well?
If you're talking about those high omega-3 oily fish, absolutely. Yeah.
If people aren't and they're looking at supplements, what are the best types of supplement to take? Because there's such a range now of supplements, and I think people get almost brain fog. There's so many different fish oil supplements. Where do they start?
I know. I would get a supplement that's got both EPA and DHA, not just one or the other. They come together in fish. They have different effects on the body. I think we can't at this point say one is good and the other is irrelevant. They both need to be there. How much? Don't have to be 50-50 exactly. Could be 60-40, 40-60. Fairly good dose of both of them, I think, is important. And trying to get probably 500 to 750 or 1,000 milligrams of EPA and DHA per day. So to get that, you can't just look at the front of the label because it'll say 1,000 milligrams fish oil typically. You have to turn the label around, or the bottle around, and see how much EPA and DHA is in 1,000 milligrams of fish oil, because it can range from 25% omega-3 to 75% omega-3. And that makes a big difference. If you're going to take a EPA, DHA fish oil product that's cheap, maybe 25% omega-3, you've got to take 4 of them to get a gram.
Yeah.
Versus if you got something that's 500 to 700 milligrams, 1 to 2 is enough to get good dose. And I think the triglyceride form is the best form. Phospholipid's okay too. It's good too. Krill. But the ethyl esters, which is what the pharmaceutical omega-3 products are made of, are not as well absorbed as the triglyceride or phospholipid forms. Those are better. Fish oil should always be taken with food for best absorption.
Now, one of the issues I can see, certainly for those of us in the UK and perhaps elsewhere in the world, the NHS doesn't routinely measure for omega-3. And we know our bodies all absorb compounds differently. So how can I know what's the right amount for me?
Well, you don't depend on the NHS to tell you what to do. We have a lab in Scotland, in Stirling, University of Stirling. Omega Quant is the laboratory I founded here about 13 years ago. And we have a sister laboratory in the University of Stirling that does exactly the same tests. We're partners with them. That test is available at omegaquant.com online. In the US, it's around $50 for a test. You get a kit sent to you. You prick your finger, put a drop of blood on the card and mail it in about a week. You get your results by email, and it'll tell you where you are with respect to your omega-3 level. And then once you've got your omega-3 index, you can kind of go on our website, and we have an omega-3 index calculator that you can click on and put in your number, and it'll tell you how much more EPA and DHA you need to eat to get your omega-3 index up to 8.
But might you have a difference between two people? Say my omega-3 index is 6 at the moment, and I've got a friend who's also 6. Might it be that I might need to eat more fish than him or her because I absorb it differently?
Totally. So this is a guess from a pooling of data from a lot of studies.
So actually what I should really do is get a baseline and then start eating my fish. I don't know how long it takes to take an effect. For a month?
3 to 4 months at the most.
3 or 4 months. Then I should get another test done and see where I'm at.
Right. That's exactly the way to do it. Just like your doctor was titrating or giving you a cholesterol lowering drug, he would test before and after you've started a drug, and is it working? It's exactly the same thing.
Now, I actually looked up what the NHS says about omega-3 supplements, and I'd be interested to hear your comments.
Yeah.
They say we don't recommend the routine use of omega-3 supplements.
Yeah. So it doesn't make any sense. And these bodies that are recommending or not recommending are doing it based on probably randomized controlled trials where fish oil is given for maybe 2 to 5 years. And they're given to people who are already ill and who are already taking multiple other drugs. Sometimes the omega-3 addition, even if it's a low dose, doesn't change the risk for heart disease, for example. And so from that, they include omega-3s don't work. And it's just silly because that is not the intention of how omega-3s are supposed to work. They're supposed to work over your entire lifespan. This is not a drug you give at the end of life to try to keep you alive longer. It's just silly.
It's not like a quick-acting antibiotic.
No. You don't cure something with taking omega-3. It's prevention. It's nutrition.
So, Bill, if you were advising the NHS on this issue, what would you tell them?
I would tell them to look at the data more broadly and look at the vast amount of data that is observational, but biomarker-based, not just how much fish do you report eating. I would look at ecological data, like Japanese versus Americans. I would look at several randomized trials, still meta-analyses show benefit for heart disease. Evidence is still out there. I say look at the whole picture. Look at the animal experiments. Look at the cell culture experiments. Look at the safety. If the oils are virtually completely safe, your need for high-level evidence of benefit goes down.
Also, when I looked in the NHS website, it's concerned about heavy metals.
Right. All the concern about mercury surrounds pregnancy and young children. And we've published recently a large study looking at all the fish feeding study, women who are fed fish during pregnancy and looking at the child outcomes, IQ, things like that. And the higher the fish intake, the better the brain function, regardless of the mercury levels.
Yeah, here we are. It's the NHS. How much oily fish should I eat? We should eat at least one portion, around 140 grams, when cooked of oily fish a week. Oily fish usually have higher levels of pollutants than other types of seafood. For this reason, there are maximum recommendations for the number of portions some groups should be eating each week.
And that's just so old. That data is so old. There was one paper that came out of Scotland about 10 or 15 years ago saying, increased pollutants in salmon from the farm salmon from the North Sea and from the Baltic. It was all about the pollutants in the food, and that's all been cleaned up. And so this is really, really old data, and they're scaring people away from a very good nutrient on the basis of a fear of a tiny amount of something that might hurt them.
And it goes on to say, how much white fish should I eat? You can safely eat as many portions of white fish per week as you like, except for the following, which may also contain similar levels of pollutants as oily fish, and that's sea bream, sea bass, turbot, halibut, and rock salmon. Anyone who regularly eats a lot of fish should avoid eating these 5 fish and brown meat from crabs too often.
Don't ask for evidence that that's harmful. Don't bother with that. We're just scared because we saw a PCB in there. Never mind how much PCBs are in milk and meat and eggs and cheese, and, don't even go there. It's outdated advice. It's not evidence-based. That's the problem. It's fear-based.
Well, Bill, thank you so much for talking today. Really fascinating. And I think people will have learned a lot. So thank you.
Thank you. It's been fun to talk with you. And I don't often get to talk with a UK perspective to hear what the NHS is saying, even though I don't agree with it.
Thanks very much, Bill. Goodbye.
Take care. Bye-bye.
Hope you enjoyed the latest episode of the podcast. And if you've enjoyed the podcast, if you could share it and leave a review on Spotify and Apple, I'd much appreciate it. It really helps. Many thanks for listening. Bye for now.